All right, today we're going to take a look at absolute value inequalities. So these are where you have a range of answers, maybe between -3 and 3, or maybe everything but between -3 and 3. And you can express these regions of the number line using not only an inequality but an absolute value. You can put them together. So I've got a few questions lined up to walk you through how this works. Now, on this first slide here, you see it says the absolute value of E is less than 10. Now, the reason I'm using E there is I want you to think about that as being almost like error. Imagine you have to make something, maybe cut something, a piece of wood, and your boss says, I need you to cut it so that it's 50 inches, but it can be plus or minus 10 inches. I know that's a big error, right? So you could cut it as low as 40 and your boss would be okay. Or you could cut it as high as 60 and your boss would be okay. Even though you missed it by 10, that's what he or she told you, right? Is to be within 10. So absolute value is always positive, as you know. So if I say the error, whether it's positive or negative doesn't matter. We're just going to throw away the sign. That error needs to be less than 10. Okay, that's how the absolute value mixed with the inequality can be useful here. So let's look at a question like this where I've introduced a little bit more than just E or X. The quantity X minus 5. The expression X minus 5, this thing in here, if we throw away the sign on that, it needs to be less than or equal to 8. Less than or equal to 8. Now, whenever you have a less than sign, this ends up being one of those between questions. All right, so what I mean by that is X minus 5 needs to be less than or equal to 8. We know that, but there's another possibility, or requirement, I guess, is that it needs to be bigger than or equal to -8. Because think about it. If the stuff inside, if this stuff came out to be like -7, for example, like if X were -2, it would be okay. Because the absolute value of -7 is 7, and 7 is less than 8. You see how that's actually a solution. X equals -7 is a solution. Or I'm sorry, X equals -2. So then you solve it. You add 5 on all sides here. There are actually 3 sides. This is called a compound inequality. You work all 3 sides. So we end up getting X is, look at this, it's between -3 and 13. You see how I called this a between question. And of course, if you draw a number line, here's -3, here's 0, and then 13 would be way the heck up here. This would be everything from -3 to 13. So we draw a line between those. So that's the between that I was talking about there. So everything from -3 all the way to 13. So whenever you have a less than or equal to symbol and you're dealing with an absolute value inequality, you set it up this way. You set it up as an and inequality where it's between those two. So here's another example. I mentioned earlier you're going to go out and have to make something, right? So let's say a part needs to be 153 millimeters, but whoever's buying this part said it can be as large as 158 or as small as 148. You see how that's 153 plus or minus 5. Now, the error, we don't care about the sign, remember. It needs to be under or equal to 5. But that expression that I wrote there doesn't have the 153 baked into it. So how do you calculate error? Like let's say your part is 155. What's the error? You know, you're doing subtraction in your head, right? You're taking your measurement, let's call it X, and you're subtracting the perfect part size, and you got 2, right? I said 155 minus 153 was an error of 2. But we throw away the sign, and that needs to be less than or equal to 5. There we go. This is what an absolute value inequality looks like that demonstrates this particular word problem where you have what's called a tolerance. So this had a 5 millimeter tolerance in either direction. All right, now what happens when it's a greater than or equal to symbol? Now, one way I like to walk students through this is let's think about some answers, some solutions. So here's 0, here's 6, and here's -6. Let me ask you this. If I plug in, let's say, -10, does that work here? Is the absolute value of -10, is that bigger than or equal to 6? It is. So down here at -10, I'm going to put a little circle, all right? So we're keeping track of where the solutions are. What about -6? -6. Yeah, that works too, right? It's equal to 6. So we have another solution here. What about -10? Yes. Okay, what about -5? No. -5 doesn't work, so I'm not going to put a dot there. Okay, I'm going to leave it blank. What about 0? Is the absolute value of 0, is that greater than or equal to 6? No, it's less than 6. So we don't put a dot here either. Now, where the dots start again, I'm sure you see what's happening here, is it starts at 6 again, and then there's more solutions up here. So the way this drawing, the way this graph looks, it's called a compound inequality, and this is an OR statement. This is an OR statement because answers are either over here, or you might have some, or you do have some over here. So I want you to think of an answer. Okay, 8. All right, that's over here. Is 8 also found over here? No, it's an OR statement. So there's a difference between and OR. And is the overlap, but OR is either here or over here. So when you have a greater than symbol, it's an OR. Greater, it's an OR problem. So let's actually work one of these out. So how do we work an OR problem? You literally write the word OR, and then you say x minus 10 has to be bigger than 3, or x minus 10. Now careful right here, careful. I just gave a quiz on this today, and a lot of students missed this. This is one of the reasons why I'm making this video. Less than -3. So let me grab the highlighter here. These are the two things that change on the second half of the OR statement, not just the -3. Now we add 10 on both sides. We get x is bigger than 13. That's where there's this whole slew of answers, is x is greater than 13. Or, if I add 10 over here, always show your work, folks, so you don't make a silly mistake. X is less than 7. Now, let's go back to our handy-dandy number line. Here's 0 over here, here's 7, and here's 13. This first one, right here, this happens to be this guy right there. X is greater than 13. But there's more answers. Well, let me use a different color here, so hopefully this helps you see. So that says x is less than 7 is another slate of answers. So I'll put an open circle here, and I'll draw an arrow to the left. All right, so there you have the graph, and I had to work it out in two different halves. By the way, let me write this in interval notation. I've been writing these as inequalities as in a graph. This would be -infinity all the way up to 7, and then we union that to the green part, 13 to infinity. And that's how we write this answer in interval notation. All right, I have one more slide, and again, it's a word problem. I actually found this one online. I thought it was a decent one. A healthy weight for a cat is 10 pounds plus or minus 1. So from 9 to 11, right? So how do we express an unhealthy weight? One of my students today said her cat was 26 pounds, and that's just insane in my opinion. I can't believe a cat would get that big, but I guess they do. So This is like that first problem that we talked about today. So if I take the weight of the cat, I'll call it X, and I subtract the perfect amount, unhealthy would be bigger, or I guess bigger than 1 pound. If we're more than 1 pound away from 10, it's an unhealthy situation. Okay? So because this is a greater than symbol, this is an or problem. So x minus 10 greater than 1, or there's more unhealthy weights over here. X minus 10 less than negative 1. Now you might be thinking, but a cat's weight can't be negative 1, and you're right. So let's just see what happens. If we add 10 over here, we get x is bigger than 11. And then over here, if we add 10 over here, we get x is less than 9. So if we graph that, folks, here's 9. Here's an arrow going that way. And then remember, I said 11. Anything under 9 is unhealthy, and anything over 11 is also unhealthy. Okay, so this was a greater than symbol. All right, so hopefully you found this helpful. Let me get rid of the screen here. Hopefully you found this helpful, and now you're ready to begin your adventure in understanding all this stuff. All right, and I really hope that you'll subscribe to my channel, you'll like this video, and hopefully some of the other videos that I posted will help you on your journey. All right, until next time.